Recently, I started on this knife as a demo for my 3D printer review, and at the time, I wasn't planning on finishing it out. However, I saw an opportunity to put the blade to use when a friend of mine gave me some hardwood from his family's farm. With a little bit of work, I figured I could turn this demo blade into potentially a family heirloom, and at the very least, a really cool gift. In addition to all of that, I need a break from the YouTube Viking Challenge build that I'm currently working on, which is turning out to be a tedious project. Sometimes a side quest like this one is just what I need to get refocused in the shop. Now, while at the time I was shooting this initial footage, my intentions were for this knife to just be a demo blank, I still went through the steps I normally would on a full tang stock removal blade. The biggest difference or deviation I made in this build was heat treating the knife in the forge out of convenience opposed to using my heat treating oven. I'm using 1084, which is a fairly forgiving steel to forge heat treat, and let's be real, while I'm a man of precision, our ancestors were heat treating knives and swords without PID controlled ovens for centuries. So I don't think that there will be any issues with the blade's performance. I brought the blade up in temperature to just above non-magnetic and quenched in Parks 50, after which I ran two 2-hour tempering cycles at 403 degrees Fahrenheit. With heat treating complete, I generally clean up the profile with my grinder in the horizontal position before hitting the flats on the surface grinding attachment. These two steps give me a nice square blade blank to work with. I started grinding my bevels with a 36 grit belt and then progressed to a 320 grit J-Flex belt. This is where I got the blade to for my 3D printer review, where I designed some detachable handle scales. I'll give these scales to the friend who'll be getting the knife, just in case he wants to play with them down the road. These are the blocks of wood he gave me, and he told me they came from a 100-year-old oak tree that had fallen on their property. The stuff seems pretty solid, and I'm excited to see how it finishes out. This slab is thick enough that I can cut out one section and split it down the middle for my scales. I'll be using this height scribe fixture I designed, which bolts to a 1-2-3 block in order to mark the center line of the block. If anyone is interested in this jig, you can get the print files by joining my Patreon or on my Etsy page. Sometimes I have a few kits made and posted on my website, but they generally don't stay in stock for very long, so get them while you can. I use the face mill on my mini mill to flatten these scales and to make sure that they are of an identical thickness. To class up the scales a little bit, as well as adding some needed thickness to the scales, I epoxied black and blue G10 liners on the inside. Using a fresh sheet of 220 grit paper and my granite surface plate, I made sure that the scales are good and flat before drilling. To prevent blowout on the underside of the scales while drilling, I added a 1/8 of an inch piece of wood to the bottom. I've been using this stacked sandwich drilling method for years, and I find that it is the easiest way to ensure aligned holes with the tang and the scales. I drilled numbered 23 holes through my tang and used an extra drill bit as an alignment pin when drilling the second hole. Using a counterbore with a 5/32 alignment guide, I bored a 1/4 inch hole about 130 thousandths into the scale. After my handle shaping, I'll come back and adjust the pockets carefully to fine-tune the depth of my fasteners. With the scales affixed to the blade, I grind down to the profile. I start with a 60 grit belt to hog away the wood, and then as I get closer to the metal tang, I switch to a 220 or a 320 grit belt. It is at this point that I will rough in my front scale bevels on the grinder and hand sand them up to 1000 grit. Now I ended up replacing these black Galso fasteners after shaping, but this is some footage of me reducing their height. Depending on which fasteners you're using, this could be necessary. I want to put a taper in the handle from the back to the front, so this will result in the front of my scales being significantly thinner. I roughen the taper and the basic shape of the handle with a 60 grit ceramic, and then blend everything with a 220 grit scalloped J-Flex belt before heading off to hand sanding. On the hand sanding bench, I work up from 320 to 1000 grit, and then finally buff with white buffing compound. Like I mentioned earlier, I carefully increased the bore depth of my holes so that a new undamaged set of Galso fasteners will sit flush with the handle scales. With the handle done, I can divert my attention to the blade. I use my disc grinder here with some 320 grit paper to knock out a lot of the big scratches in my finish. This greatly reduces the amount of time spent hand sanding. After that, I hand sanded this blade up to a 320 grit finish, getting all the scratches moving in the same direction. In reality, I probably should have taken this blade up to 600, but I got a little lazy. Before I stonewash this blade, I'm going to be etching in my maker's mark with my new fiber laser. I ran this etch at 50% power, 50 millimeters per second, in 25 passes. If you're interested in this machine, I'll put a link to my full overview in the cards above. To etch the blade, I'm going to be using a new etchant to my shop called Gator Piss. I bought this stuff for my Damascus work, but figured I'd give it a test run here. It got the job done just fine with this knife, and I'm excited to use it on some of my intricate Damascus patterns in the future. After etching, I tumbled the blade in my stone tumbler for about 15 minutes. I think I would have gotten a cleaner etch and stonewash on this blade with a 600 grit finish, but for a working knife, I think this will do just fine. Using my disc grinder, I hogged away some material on my secondary bevel in order to save me some time with the Wicked Edge. As many of y'all could tell from my Wicked Edge sharpening review, I really love this machine, however the biggest drawback is that it takes some time. Setting the secondary bevel on one of my grinders or on the water wheel really speeds up the process. I sharpened this blade with a 20.5 degree angle and worked up to the 1000 grit stones before stropping with the leather strops. On the final assembly of this knife, I installed the new stainless steel Gulso fasteners into the handle scales and put a dab of blue thread locker on there just for good measure. I also made sure to lightly oil the tang before assembly since this is 1084 that could rust if water gets trapped in there. Using this little torque driver, I torqued the fasteners to around 15 inch-pounds. Now I can't give this knife to my friend without a way to carry it, so I started on a basic right-handed carry pouch sheath. I'm going to be hitting the highlights here, but if you want more info on how to make one of these sheaths, I have a full detailed tutorial on my channel and will put the link in the cards above. You may not have noticed, but I made a big mistake when cutting the sheath out on my laser by putting my maker's mark up on the sheath's body very high. Luckily, this mistake will be mostly covered by the belt loop stitching. Speaking of the diode laser, the one I'm using is a 20 watt from X-Tool and has really increased the success rate of my sheaths by providing precise templates. If you're interested in this machine or other tools I used in this build, check out the affiliate links in the video description below. The use of these links really goes a long way in keeping this channel operating, so thank y'all greatly for using them when you do. I used a 4mm space pricking iron to mark out my holes in the belt loop for drilling. When drilling these holes, I'm not using a traditional drill bit, but instead I'm using a large-ish OD needle chucked in my drill. This simulates a punch, and I feel like it's a better option than a drill bit. Since my maker's mark from the laser is now covered by the stitching, I used my stamp from Ghost Graphics to mark the sheath. My barge contact cement dried out, so in a pinch I was able to get my hands on this leather crafting cement. I'm sure it's not as tough as barge, but I did do some testing with scrap pieces, and it held up pretty darn well. The leather seemed to have failed before the glue did, so I will consider that a win. I get the welt glued into the sheath, and I leveled the 3 edges on my belt grinder with a 120 grit belt and some quick slick on the edge. Just like I did on the belt loop, I marked out my stitching holes with pricking irons and then drilled them with my mini mill. I ran a locking saddle stitch all the way down the sheath and did 2 back stitches at the end. Some key points here is that I normally do 10x the length of my stitch line to measure out my thread, and I'm using John James Saddler's harness needles, which are awesome, by the way. At this point, I gave the sheath a whole coat of neat's foot oil and then gently heat the sheath for better absorption. I dyed the edge darker and then finally gave the sheath a bag coat finish for protection. Alright, so this is how the sheath turned out. Other than the mishap with the maker's mark, I'm very happy with this sheath. I'm very thankful to Paul Long and his DVDs for showing me the ropes of leatherwork, and while I'll never meet the man, I'll always be grateful for him taking the time to showcase his skills. If y'all want to get better at leatherworking, his DVDs are well worth the dollars. I think this side quest of a knife that started off as just a demo has potentially turned into a family heirloom for my friend. I hope this knife gets some good use on the farm where this oak tree fell. Speaking of the oak, I'm actually shocked at the beauty of the grain of this wood, and I really like the light color coupled with the liners. When it comes to the rest of the knife, y'all may have gathered that I'm becoming partial to takedown handles on full tang knives. I like how easy this type of handle construction makes keeping the finish contiguous along the spine, how it provides for easy handle replacement in the future if needed, and just the overall ease and benefits to the maker when building the knife. Now don't get me wrong, I like how this knife turned out, but it's not perfect. I know many of y'all watch this channel to garner some tips and tricks in knife making, and in an effort to save you guys some time, I'd love if y'all could learn from my successes, failures, and mistakes. That is why I generally go over the flaws or non-ideal outcomes of my knives at the end of my videos. On this one, the biggest issue is probably the evenness of the blade finish. The two things I can attribute this to is heat treating the knife in my forge instead of my PID controlled oven, and not working up the grit to at least 600 before etching. Both of these were done for speed and convenience, and are not what I'd consider best practices. That being said, I do think this forged heat-treated 1084 blade will be a good performer for my friend. Obviously, if he ever has any issues with it, I'll just make him another one. The other issue I have with this knife is that I should have taken just a little bit more time flattening the tang. I noticed at the end of the build just a slight amount of daylight on the scales at some sections that disappear when applying pressure. It's minor, but once again, not best practice. So with all that commentary out of the way, I really hope y'all enjoyed this side build. Make sure to subscribe to the channel and hit the bell notification icon so y'all don't miss out on the Viking Challenge build coming up in April. Until the next time, I'll catch y'all on the flip side.